Good evening, all. Welcome to Metro West Climate Solutions program here on Thursday, June 5th. I am Jeff Barcel. I'm a member of the steering committee. I'm joined by Evan Hottingham, who's also a member of the standing committee, and our speaker, our guest for this evening, Professor Steve Young from Salem State University. We're delighted to have him here with us this evening. I'm going to turn it over to Evan for a welcome and introductions. Evan.
Hello, everybody. My name is Evan Hottingham. I'm a member of the steering committee of the Metro West Climate Solutions. And Metro West Climate Solutions is a partnership of a number of committees on local First Parish churches. That includes First Parish Weston, First Parish Wayland, First Parish Lincoln, and Framingham. Also Seafree and Lincoln, and Energize Wayland, and many other organizations and individuals. And we're a growing list of people concerned with the climate challenges that are in our future. For the mission of the climate solutions is to work towards sustainable, resilient, low carbon communities, and also to host timely, relevant programs focused on solutions. And you can see some of those past events. A wide diversity of speakers. If you log on to metrowestclimatesolutions.org, well, you'll see recorded videos of the presentations. Tonight is the third in our series on the impacts of climate change in the Northeast and what to expect and how we know about the science involved. We're very lucky to have as our speaker Professor Stephen Young, an ecologist and biogeographer at Salem State University. Now, Professor Young got a master's degree at Yale in forest ecology and a PhD in geography at Clark University. And he has done field ecology studies in, he says he's visited 60 countries and spent his early career living for long periods in China, Australia, and India, and he continues to be a prolific co-author. But at Salem State, the focus is not just on research, but it's about training students at all levels on the methods and practice of doing science, particularly the remote sensing and satellite imaging in which he's specialized. Beyond that, however, Professor Young does very broad public outreach on climate change issues to people of all ages. And you're about to see what an effective communicator he is on those issues. So for the last 5 years, he's focused on using those imaging technologies to monitor snow cover in the Northeast. So he's come from his global perspective, really been focusing on the future of New England for the last 5 years and what's going to happen in the future. So with that, I'm very excited to turn it over to Professor Young.
And let me just, Evan, I could just jump in real quick. When people have questions and comments, we encourage them to use the Q&A button on the bottom of their screen instead of the comments. And we will try to get to as many of the questions and answers after Professor Young's presentation. Professor Young, welcome.
Great. Well, thank you. Thank you, Evan, and thank you, Jeff, for inviting me here and giving me a forum to talk with people. And I'm especially glad to be talking to a group that also engages in the spiritual dimension of climate change. I'm a scientist, but I'm also a member of the Unitarian Universalist Church of Greater Lynn and see a real important aspect of the spiritual nature when confronting issues of climate change. Sometimes when I talk, I might get a little preachy. Right? Preaching is with passion, trying to educate people. I'm passionate about science. And before I start, I want to tell you a little story. Back in I think it was about 2016, our church has what they call the Winter Forum, and we've had different topics, and I gave one on climate change. And when you're lecturing in person, a lot of times when someone's really engaged with you, you kind of start to talk to them, and I noticed near the end of my talk, there was Francie, and she was on the edge of her seat, and I was talking, kind of looking at her, and then I noticed there's Jim, there's Trudy. All of a sudden, I realized that there was the choir, and I was preaching to the choir. And in my head, I just wanted to yell, "Oh my God, I'm preaching to the choir." But at the same time, I was talking about the connection of all the different um, issues of climate change. And so my brain was split for a little while. But kind of a funny incident. Sometimes I feel like I'm preaching to the choir and that I'm talking with people who already know about climate change or are concerned about climate change. But hopefully, I will give you a different aspect to think about tonight. And I'm going to start my talk with some basic levels. And so I want everybody to be on board when we talk about more thorough issues that are happening in New England. Um, so, uh, okay, good. Um, where did the snow go? Climate Change in New England is the title. And tonight, I'm going to talk about the science of why our climate is changing. Then I'm going to talk about changes in New England and why southern New England is seeing less snow and some other climate change issues, and then what to do about it. And I'm going to try to do this in about a half an hour. I teach a semester-long class on climate change, so there's a lot of stuff that I'm gonna leave out and try to focus on the main three issues here. So first of all, um, we live in an amazing planet. As Evan said, I have an ecology background, and I spent many years living abroad, working on various ecological things. And the one thing that I got out of it was just how amazing and how diverse our world is, and all the different forms of life that share this planet with us. And so sometimes it can get a little depressing when studying how things are going, but trying to remember about the amazing planet that we live on. Speaking of which, I've got a quiz to start. I want you to think about, what do you think was the last week was the hottest place on Earth, and how hot was it? And what was the coldest place on Earth, and how cold was it? Um, I'm going to give you 1 minute or 30 seconds to think about what the extreme temperatures on Earth might have been. All right. Last week, the hottest place was in Pakistan at 126 degrees Fahrenheit, and the coldest place was the Russian research station Vostok in Antarctica at minus 105. So the difference in temperature that the Earth experienced last week was more than 231 degrees, more than from freezing water to boiling water. Just one example of the amazingness of our planet. Right. We live on this very complex planet, multitude of interactions, natural interactions, human interactions, and one way to understand this incredible world is through science. And so what is science, right? Most of you, I'm sure, know what science is, and many of you are probably involved in science, but it's a method. It's a way that we understand the world. It's based on observations. We go out and we make observations in the world, and then we come up with conclusions based on those observations. It's transparent. There's nothing secret, and we're running experiments all the time to see if those observations are playing out throughout the world. Instruments, we've got lots of instruments to make observations of focusing on the weather and climate on our atmosphere. And just one instrument I wanted to point out tonight are these ocean buoys that measure temperature in the ocean, right? More than 70% of the surface of the Earth is covered in water. And the oceans are very deep, so there's a lot of energy being stored and released from the oceans. And so these buoys, what they actually do is they go down to about 1,000 meters deep in the ocean. They drift around for a while, 9 days, taking temperature, salinity, a number of different observations, and then drop down to 2,000 meters, creating a profile all the way down. and then they rise back up to the surface of the ocean, and they transmit their data to a satellite, then to a receiving station, and scientists deal with that data. We've got a lot of these buoys throughout the ocean. We've got lots of thermometers throughout the world to give us a good understanding of what the temperature on Earth is. And so this is a graph of all those observations that we've collected, and we have good data going back to 1850. And so this is a graph of global temperature from 1850 to 2023, and this gold circle is last year's average global temperature, which is the hottest it's been in this realm. And each of those black dots are what we call an anomaly. And an anomaly is how far something varies from an average. And in this case, we took a global average of temperature from 1850 to 1900. So we added up those 51 years, divided by 51, and it gave us an average. And then we looked at the temperature for every year, the global average for every year, and how did it compare with that long-term average? The gold circled anomaly here from about 1878 was 0.4 degrees Celsius warmer than that long-term average. And the blue circled anomaly was minus 2.2 degrees Celsius cooler than that long-term average. And this is a way that allows us to see how temperature is changing on Earth. And the red line that runs through the middle is a long-term average. It's a 5-year average of all those black dots. So it kind of smooths the data out. And one thing we've noticed is between 1960 and 1980, there was a significant change in the direction of temperature, going from a relatively stable period to one of increasing rising temperatures. And they don't rise year after year after year. As you can see, there's a lot of up and down fluctuation because of the complexity of the Earth system, but the long-term average has clearly changed and is rising. Also, I want you to note are these little black lines, and for each black dot, each anomaly has these black lines which refer to what we call confidence intervals. How much error is there? This black dot actually could be, we're 95% sure that it's there or it's anywhere on this line. And notice that these error bars have gotten significantly smaller in modern times. We have a very accurate measurement of temperature on Earth now. And so we're very confident in the data. And even the older data, we have great confidence, but we show these little errors. It's one thing science does. We always also say what we don't know. So here is looking back further before we had thermometers. And there's a variety of ways, and in a little bit, I'm going to talk about one of the ways that we look at past temperatures. Also in science, we look at as many data sets as we can look at to see how patterns occur. And so these different colored lines are different data sets that go back to the year 0, so the past 2,000 years. And you can see there's some variation, but they pretty much show a similar pattern. The red line is thermometer measurements. And so these thermometer measurements are pretty close to these, what we call climate proxies that show us temperatures in the past. But one thing we notice is that the temperature today, and I actually added to this graphic what it really is at the end of 2023. We are significantly in a different temperature realm than we have been for thousands of years. Why is the temperature on Earth the way it is? It's actually pretty simple. We get almost all of our energy coming from the sun, 99.99%. And anybody that has energy radiates energy away. And so the Earth also radiates energy back to space. And so the Earth's temperature is the difference between the incoming solar radiation versus the outgoing Earth radiation. And we've discovered that we are not receiving more incoming solar radiation. That's not why the world is warming up. In fact, the yellow line in this graph is measurement of incoming solar radiation to the Earth system, and the red line is temperature. And we can see again that period between 1960 and 1980, there's a decoupling of influence of the sun on the Earth's temperature. So it's the reason why we're warming is not because we're getting more incoming energy. It's that we've changed the chemistry of our atmosphere that's not letting the energy leave the Earth system. And so greenhouse effect, which I'm sure you're all familiar with the term at least. And so there are gases naturally in our atmosphere, carbon dioxide, methane, water vapor, and these gases let the sunlight pass through them, just like the glass of a greenhouse lets solar radiation into the greenhouse. But these gases absorb and re-radiate the terrestrial radiation, some back to Earth, just like the glass of a greenhouse stops the heat from leaving a greenhouse. The greenhouse effect is a natural effect. The problem is we are enhancing the greenhouse effect. We're increasing the greenhouse effect. We're putting more and more of those greenhouse gases in our atmosphere, which leads to more energy being re-radiated back to Earth. So Earth's temperature is like this ducky in the bathtub. As long as the amount of water coming into the bathtub is equal to the amount of water leaving the bathtub, that ducky's going to stay at the same level. But what we've done to the Earth system is we've squeezed the drain pipe. We're not letting out as much energy as we were. And so what happens here, as long as you've got a similar amount of water coming into the tub, you're going to have a rising tub of water. And right now on Earth, we are filling up with energy. We're not letting as much energy leave the Earth system, and so it's being stored in different places on Earth. We have satellites that can measure, that you don't have to read these words, it's just to prompt me about this image, is we have satellites that can measure very accurately the amount of energy that's leaving the Earth system, and we have satellites that can measure very accurately the amount of energy that's coming from the sun. And one thing with science, we quantify everything. We're quantifiably receiving more energy than we're sending back out to space because of the greenhouse effect. Where is all that energy being stored? Well, most of it's being stored in the oceans. And that's one reason why we don't feel the effects of climate change so much, is because those oceans are storing that energy. We're seeing a mass migration in our oceans right now. There used to be a healthy lobster industry in Long Island Sound, and those lobsters have been migrating north out of Long Island Sound up into Maine and up into further colder northern waters. And now there is virtually no lobster industry in Long Island Sound. And our oceans continue to warm and store this energy. One thing that helps us understand climate change is understanding how our climate has changed in the past and what have been the drivers of those past change. And one of the greatest tools, we call these climate proxies, things that can tell us about the past climate, are ice cores. And ice cores, snow lands on Antarctica, and it presses down on past snow, which turns to ice and more snow on top. So as we go deeper into Antarctica, we are seeing the climate from years past, and we've got ways. There's air bubbles trapped there, so we know the chemistry of the atmosphere. Also, there's a process called oxygen isotope analysis, which we can take the oxygen molecules and determine what the temperature was in the past. And so here's a graph, and it's looking at carbon dioxide concentrations and temperature of the past, going from the present day here on the right all the way back to more than 422,000 years ago. On the left-hand side is the scale for carbon dioxide concentration in the atmosphere as captured in those air bubbles. And on the right is the temperature as captured by the oxygen isotope analysis. And we can see there's a strong relationship between carbon dioxide and temperature. Carbon dioxide and the other greenhouse gases are known as the thermostat of the Earth's temperature. And I'm not going to go into detail about how we know that this relationship is very accurate. We've done a lot of experimentation that when levels of carbon dioxide drop in our atmosphere, Earth system gets cooler because more energy can leave the Earth system. When there's more carbon dioxide in our atmosphere, the Earth warms up because not as much energy can leave the Earth system. And here's another sample. This goes back 800,000 years. And on the bottom here, we see temperature in degrees Celsius in Antarctica. And here we see carbon dioxide concentrations in the atmosphere. And again, we can see that relationship. And here's our current level of carbon dioxide in the atmosphere. It is completely out of what the situation has been for the past 800,000 years. And you can imagine that the temperature is going to continue to rise unless the laws of physics have changed. I grabbed this last month in May. This is atmospheric concentration out in Hawaii. In 1958, there was this graduate student who wanted to measure chemical composition of the atmosphere, and Hawaii is a great place to do it because there's a volcano that sits way up in the atmosphere, and Hawaii is away from a lot of the industrialized world. And so we get a good sample of the Earth's atmosphere. And one of the things he collected was carbon dioxide. And again, that black line is the long-term average, and the up and down squiggles is the exact measurements of carbon dioxide. The bottom is the years going from 1958 up to 2024. And on the left is the concentration of carbon dioxide in our atmosphere. And we can see that it keeps going up, keeps rising. And in fact, last year we had the highest amount of carbon dioxide in our atmosphere since we started measuring in 58. Here is a closer look at it. And I just wanted to show you that there is no indication in the atmosphere that humans are doing anything to stop the admission of carbon dioxide into the atmosphere. Here's methane, which is another major greenhouse gas. I took this in May of this year also. And there was a period where methane concentrations in our atmosphere leveled off. But then we learned how to frack, and we started cracking the earth open, and a lot of methane has been released, and we're using methane. And methane in our atmosphere is also continuing to increase. And in fact, the rate of methane in our atmosphere is accelerating. The Intergovernmental Panel on Climate Change is a group of science. A lot of times in science, we focus in one specific area. Sometimes, right, the ivory tower, we don't coordinate with others. So the IPCC, what they do is they look at all the research and all the different disciplines, and they try to see how they're related to each other. And they have come up that if we want to have want to reduce catastrophic climate change, we really need to keep global temperatures from rising less than or equal to or less than 1.5 degrees Celsius since pre-industrial times. It's kind of a threshold that scientists agree that if we go over that, things are going to get more difficult to fix. Here is how much carbon dioxide we put into the atmosphere between 1940 and 2023. Again, at the bottom are the years. And on the left is the atmospheric amount of carbon dioxide put in the atmosphere. And last year was a record year. We put more carbon dioxide in the atmosphere than any year that we've been measuring. That teeny dip, that teeny little V that you see here near the end was due to COVID. And during COVID, it seemed like we were cutting way back on our greenhouse gases, but it was really just a small blip. And one thing that has become popular now is to pledge to be carbon neutral by 2050. And if we are going to succeed at that, this this trend of carbon dioxide going in the atmosphere really has to drop dramatically. We have to turn that momentum in almost a U-turn fashion. Right, Massachusetts legislature commits to net zero by 2050. Salem State, Salem, a lot of organizations have done that. given that commitment, that is what we have to do to reach that commitment. And in fact, a lot of scientists have said that to have a stable atmosphere, stable climate, that is a very livable climate, we really should reduce the atmospheric concentration to 350 parts per million. Right now, it's right over 420 parts. So not only do we have to get to net zero, but we really need to pull carbon dioxide out of the atmosphere as well. So that's the situation that we're in, and to review, we know through experimentation, through observations, that carbon dioxide and temperature are tightly controlled with each other. As carbon dioxide goes up, temperature goes up. As carbon dioxide comes down, temperature comes down. Currently, we keep putting carbon dioxide into our atmosphere, and we currently see that our temperature is rising because of that. It's very clear, the situation. One thing that's not as clear to people, it has to do with moisture in the air, water vapor in the atmosphere. There was a saying that it's too cold to snow, and that's true. What this graph shows us, as on the left is 0 degrees Fahrenheit, the bottom is temperature in Fahrenheit, going from 0 to 120 degrees, and the vertical column has to do with how much water the atmosphere can hold, the potential amount of water in the atmosphere. And when it's cold, the atmosphere can hardly hold any moisture at all. And in fact, when it does get below 0, it is very difficult for it to snow because there's almost no moisture in the atmosphere to snow. As the Earth gets warmer, the atmosphere can hold more moisture. And it's not just that each year can hold a little bit more, it's what we call an exponential change. And so when we go from 20 degrees Fahrenheit to 40 degrees Fahrenheit, we see that the atmosphere can hold a little bit more moisture. Not a whole hell of a lot. All right, it's still pretty cold, and so the atmosphere has no room for moisture. However, when we increase the temperature of the atmosphere 20 degrees, like we did earlier, from 80 to 100, it can hold a tremendous more amount of moisture. And so this is an exponential change. And as the Earth warms up, it is all of a sudden can hold this tremendous amount of moisture. So what's happening is, as our world as we put more and more carbon dioxide in our atmosphere the Earth is warming, and the atmosphere, as it warms, can hold much more moisture. And warmer air can increase evaporation and can hold more moisture, leading to droughts. And so we've seen in the past few years a lot of droughts around the world. Some incredible droughts occurred in China in 2022 due to global warming. Also, by being able to hold more moisture, when it does rain, it can rain a lot, leading to floods. And so this was in China. This was a 10-year-old subway system that completely flooded. And even people that were inside the subway cars, the water filled the subway cars and they drowned. That the subway system completely filled with water, and they hadn't predicted that they would get so much rain. Recently, Death Valley, which is sometimes one of the hottest, driest places on Earth, had a lake where people could actually kayak in it because of the flood. They received more than a year's worth of rain in one day. Dubai recently received a year's worth of rain in one day. Anyway, there's been lots of droughts and there's been lots of floods, which is a direct cause of the atmosphere being able to hold more moisture because the atmosphere is warming up. This is a research paper that Jia Chang Tu was a graduate student at Salem State, and this was her master's thesis. And when we started looking at flooding conditions in Shanghai, we looked at 10-year floods, 100-year floods. We even looked at 1,000-year floods. And I thought, right, looking at a flood that might occur once in 1,000 years seemed, when we started this project in 2020, seemed kind of outrageous. Now the world is seeing 1 in 1,000 year floods fairly regularly, like in Dubai, like in Death Valley. So just in the past couple of years, my view, even being immersed in the science of climate change, my view has changed dramatically to how impactful the warming is on the water cycle and droughts and floods. So that's the cliff notes of the science of climate change. Now looking at New England, so uh, a few years ago, I published a paper with my son Joshua. Actually, it's called "Overall Warming with Reduced Seasonality: Temperature Change in New England," and we looked at data from 1900 to 2020. And these are the weather stations that we looked at, and these stations, the data and this is the best data possible. The data is calibrated. If there's any changes that happen with instrumentation or moving the instruments, it's all been calibrated so that is as the least amount of error in the data as possible. And one of our major conclusions from this was that minimum temperatures in New England are rising the fastest. So here's a graph. I took all 44 stations in New England, and we looked at the annual temperature change, and we found that between 1900 and 2020, New England increased an average of 1.83 degrees Celsius. And those double asterisks means that we're 99% confident, and a single asterisk means we're 95% confidence. And we see that the minimum temperature has risen over 2 degrees Celsius for New England. And the minimum temperature has risen also in the summer, the fall, and in the winter. And not only has the winter minimum temperature risen, but also the average and maximum winter temperatures have risen as well. So what's happening in New England is our winters are getting warmer, and our minimum winter temperatures and our minimum temperatures throughout the year are also getting warmer, which is another reason why people don't feel it as much as we would if the maximum temperatures were increasing. Because who doesn't like a warmer day in winter, right? Those super cold days are not fun. And so it's actually making it more comfortable in New England, having these minimum temperatures rise. Here's a graph, again, time along the bottom from 1900 through 2010s, and I aggregated the data by decade. And the orange line is New England, and the blue line is the globe. And these error bars mean that point could be anywhere along that black line. And because we don't have as much data as the global analysis, means that there's more error in the New England data. But if these error bars do not cross each other, it means there's a significant difference between those two data sets. And what we see is that New England is warming now much faster than the globe as a whole. There's my son. It was during COVID. He was home from college, and I said, "Why don't we do some kind of data project together?" And we did. And when we saw the results, we were like, "Oh my God, we have to publish this." And then it got picked up by the Globe and others. Not only is the land area's temperature rising in New England, but the Gulf of Maine is warming faster than most other water bodies around the world because the Gulf Stream is pushing further north now and pushing warmer water into the Gulf of Maine. Another paper I did with a graduate student, Kristen Thibault, we looked at snow cover change and its relationship with the temperature of the surface of the earth and vegetation in northeastern North America using satellite data between year 2000 and 2017. And when there's snow on the ground, most of the sun's energy reflects back to space, and very little of that energy is absorbed into the Earth system. When there's not snow on the ground, less of it's reflected, more of it's absorbed into the ground. And the conclusions of our study, we used the NASA Terra satellite surface temperature and snow cover, we found that when I say snow cover, I'm looking at is there snow on the ground or not snow on the ground? And we discovered that in northeastern North America, snow is declining 12 times faster than it's increasing. So some places there's a little bit more snow cover, but 12 times as much as disappearing. And we also discovered that, not surprisingly, that there's a strong relationship between decreasing snow cover and increasing land temperature. So one of the reasons why the winter is warming is because less of the sun's energy is reflecting back to space and more of it's being absorbed and heating the winter. And finally, I recently published a paper. I looked at the whole world as well as different regions, looking at snow cover decline with satellite data from 2000 to 2022. Again, I used the NASA Terra satellites. And conclusions were that globally, snow cover declined 10 times faster than it was increasing. Between the year 2000 and 2022, over 5% of the world's snow covers disappeared. And it's not happening everywhere. There are certain regions where it's happening faster than other regions, and these are called hotspots of decline. And one of those hotspots of decline is southern New England. Those red spots represent the top 5% of global snow cover decline, which is melting faster than all the other areas that are declining in snow cover. And so our part of the world is experiencing, and you have to have your head in the sand if not to notice, if you've lived around here for a while, that we are getting less snow cover. There's less snow on the ground. And here is, I looked at all of New England. I actually looked at some more recent data. And so in the winter season, which has a total of 90 days, Connecticut has lost 25 days of snow cover in the past 24 years. Rhode Island, 19 days, Massachusetts, 20, New Hampshire, 10, Vermont, 9, and Maine, 5. So Maine's not losing as much snow cover as southern New England, but it is disappearing quite quickly here. And one of the main reasons is, as we saw, winters are not as cold as they used to be, and the minimum temperatures are not as cold as they used to be. We're still getting as much precipitation in the wintertime as we used to, but now when it's 35 degrees and raining out, in the 1970s, it was 28 degrees and snowing. And so we're at that area of the world where those winter temperatures are rising and that precipitation is coming down as rain instead of snow. And when it does come down as snow, warmer days appear and melt that snow. Precipitation changes in New England. Overall, precipitation is increasing. We're actually getting more precipitation than in the past. We're getting heavier rainfall, heavier storms. It's not coming as gentle as it used to, which means it runs off quickly. It increases erosion. There's less infiltration into the ground. We're getting more precipitation in the wintertime, but the rain to snow ratio is increasing, which means it comes as rain more often than snow. We're getting this weather whiplash, wet to dry, hot to cold. Summers are getting hotter, not as fast as winters, but they're getting hotter and they have a similar precipitation. So there's this increased water stress on our summers. Here is a graph of changing precipitation conditions in continental North America. And you can see New England is getting more precipitation than in the past. This is getting a little out of date, but this study looked at heavy precipitation, and Northeast our precipitation is coming more heavily now than in the past. So that's a little bit about the science of climate change, a little bit about what's happening in New England. So what to do about it? First of all, a student recently in my climate change class wanted to know why all of a sudden are scientists interested in climate change, and it's not all of a sudden. Here's a paper published in 1896. It was the first calculation of global warming from human emissions of carbon dioxide. We've known that that humans putting carbon dioxide in the atmosphere will warm the world for a long time. Anyway, I just wanted to get that across because I was so stunned when the student said that. Maybe it's because it's getting in the media more. I'm not sure. So fighting climate change, what to do is no longer just up to individuals. Change really has to come at the societal level. In 2004, the British Petroleum came up with the concept of an individual's carbon footprint. They had a lot of pressure on them. Soon after, and a few years later, came an inconvenient truth, and so people were beginning to understand about climate change. And so they put the spotlight on the individual and said it's the individual's got to cut down their carbon footprint instead of putting the focus on the producers. And eventually, someone did a carbon footprint of a homeless person in Boston who uses very few resources, but they still had a carbon footprint because the system in which they live did not allow them not to. And where we're at right now is we need to create an infrastructure that we can live in, which does not exacerbate climate change. An example of things we shouldn't do out in your area, Metro West, right? There's the Hanscom Airfield. There's the proposal to increase it, to have more private jets. Right, private and business jets are one of the dirtiest forms of transportation. There's little evidence that the aviation industry is really going to be able to solve their high carbon form of transportation anytime soon. Private business and jets are not a necessity. We've got public airports such as Boston Logan. Reports have indicated that the expected carbon emissions from the private planes would negate 70% of the climate benefits of all solar PV ever installed in Massachusetts. Whether it's 70% or 50%, that's going to put us backwards. Remember, I showed you that graph where we have to dramatically bring down our carbon dioxide emissions in our atmosphere if we're going to be carbon neutral. Private jets also embody a striking example of carbon inequity, in which the most privileged few contribute significantly into climate change, while the impacts are often experienced by those less privileged and least resilient to climate change. The science is absolutely clear. Our world is warming, will continue to warm until we reach net zero and reduce current levels of atmospheric greenhouse gases. Another example is cryptocurrency. It's anticipated that from this year until the year 2030, demand for natural gas is going to increase about 10% per year solely for the mining of cryptocurrency. We have to change the infrastructure in which we live in. Our economic system currently is very divergent from the functioning of the natural world. Right, here's our predicament. Our world is warming, will continue to warm until we reach net zero or a little after, really. Stopping climate change is no longer an individual effort. Sure, we need to do what we can individually, but it really requires society to prioritize reducing greenhouse gases, especially in the infrastructure that we create to live in. At Salem State, I did want to let you know that we also have that carbon neutral goal, but we've been very active divesting in fossil fuels, greening the grid at campus, putting solar panels on as many buildings as possible, LEED certified buildings, geothermal for our library. We have a decarbonized plan, which has recently been given $50 million to move forward with to decarbonize our campus. We're also trying to change the culture. We have dorm composting. We've upped our recycling. We're electrifying campus for cars. We've got the blue bikes on campus. My department, we focus on technology and sustainability. So we are learning how to fly drones, use satellite data, use geographic information systems to combat climate change. Our main focus is on technology and climate change. We've got public exhibitions such as this one, climate change taking action with modern mapping techniques, educating the public about how we can use various mapping techniques to help us combat climate change. We also have a professor who works on climate and equity, which is one of the more ethical and spiritual aspects of climate change. Our future is arriving now. Our climate, which has been relatively stable for a long time, the past 8,000 years or so. Sure, there's been variation from year to year, decade to decade, but it's been relatively stable, but that has now changed. We are going from a world of climate stability, certainty, to one of instability, uncertainty. The driving force of climate change is the continuous production of greenhouse gases, which causes a continuing warming of the planet, as we have seen. Our economic system, which was very successful in a stable climate, is now detrimental in a warm climate. A couple of years ago, the companies, the section of our economy that was making some of the greatest amount of profits were the fossil fuel companies, with very little of that profit going to fix the problems of climate change. We need to change the very structure of how we live, especially how we use energy. It's in our hands how hot the future will get, but things are starting to change quickly. I kind of raced through that a little bit, and now I will stop sharing and will be open to questions and discussions about what I talked about, and thank you.
Thank you very much, Professor Young. That was quite a tour and quite a tour de force of sorts, with a great reminder of some of the science of climate change, and then quickly moving into the impacts, and then the solutions, or at least the responses to the necessary strategies for engagement and reduction. So that was excellent. Just a reminder to everyone who is with us, our Q&A section is now open, and we welcome comments, questions posed through that venue or a function here in Zoom. And let me just see, we already have a couple comments, and I know that people are going to want to talk probably a little bit more about the private jet expansion at Hanscom. You touched an important and sensitive button here locally in the Metro West area, Steve, and we're glad you did that. But let's just start with, let's see, Joel, what has the greatest impact on our plants, animals, and insects in New England? Higher max temps, higher min temps, changing precipitation, snow cover, or is it all of the above?
So that's a great question. And that is not my area of research, but I did recently talk to an entomologist who works up in Hubbard Brook in New Hampshire. And the insect population over the past 3 decades, the weight of insects, or the amount of insects, has dropped by about 50%. And it's not just there. There's many sites around the world, and life has a certain range in which it can survive in, and temperature and moisture are those key aspects, and also stability. And so I don't know the answer, but certainly I would imagine that it is those minimum temperatures, right? They kill off pests that then, when those minimum temperatures rise, other species can move in and can outcompete, or the food source changes. I do know with some bird species that migrate, plants are leafing out earlier, insects are coming out earlier, and then insects are moving on to either becoming butterflies or whatever, and the birds arrive, and the insects have already left. And so there is a great disruption of the food system also.
I know what Bill Kibben likes to say, that nature is on the run, and many of the species are losing as a result. They're
Right.
not equipped to migrate.
Right.
I
And
also
we,
know,
our conservation ways, we set aside a piece of land and we say, okay, this land is going to be there. And then we build roads around it and everything. And so they can't move. They can't migrate.
it literally can't move. I know around here at least, there's a lot of complaining and opining about what appears to be an increase in the tick population.
Yes.
Because
Yes.
we're not having the same number of super cold days in the wintertime to knock down ticks. And I guess that's a problem being reported up in Maine and elsewhere with where,
Tick population is moving northward. Yes. In a lot of places in Vermont have never had it before, now having it. Yes.
yeah, there's even the phenomenon of ghost moose.
Yes.
Moose that have so many active ticks on them that they are just emaciated, and it's just sad.
And young moose actually die.
Yeah,
And
it's very
it's
sad.
amazing that an insect that's smaller than my pinky fingernail can kill a moose.
Yeah, I can sometimes kill a human being too. You have to be careful.
Yes.
Let's see, Tom asked our comments. It's clear from your talk that we know a lot about the science of climate. So where are the most critical remaining challenges that climate scientists must address to guide us to effective policy solutions?
Well, my area is education. And as a scientist, I think that a lot of people are aware that it's happening, but not aware of right. After seeing what I talked about, I think you can see where we're headed towards, right? And not only is it going to be warmer, but the drought and the storm activity and the momentum of greenhouse gases going in the atmosphere and continuing to do things like expand private jets, cryptocurrency and stuff. I feel the science is very clear. It's that the politicians, it's that people need to understand it. And so I feel the most critical area is education, science education. We know the issue. We have the solution. We've got the technology of solar panels and wind power and alternative energy sources. We've got planners who know how to plan cities to be livable and create less greenhouse gases. We've got the finance to do it. We've got the know-how to do it. It's just I believe the education and the awareness is not there.
Yeah, I know. Sometimes I hear communications researchers talking about shifting the Overton window, that window of possibility that that's corporate that in total that society has at any given time, and making sure that people see these as viable options and indeed urgent ones
Right.
pathway
Right.
forward. Steve, let me just ask you, or excuse me, Professor Young. I know you, so I'm calling you by
Okay.
Steve.
Is okay.
Ross asked in the 800,000 year graph of CO2 earlier in your presentation.
Yeah.
He says there were 5 series of stark increases in CO2 that he saw in that 800,000
Yep.
year
Yep.
graph.
Yeah. Yeah.
What caused those peaks?
So one thing, so temperature and carbon dioxide are related to each other. And so what caused those changes was primarily the changing orbit and tilt of the Earth. So the Earth is wobbling in space in like a 44,000 year cycle that the tilt changes. And its orbit changes from a very circular orbit to an elliptical orbit. And that changes the amount of energy coming into the Earth system. So when there's less energy coming into the Earth system, Earth gets cooler, and as it gets cooler, less carbon dioxide is being released from plants. Less carbon dioxide is being released from permafrost from the Earth system. It's being locked up, and then when the Earth's orbit and tilt changes, it starts to warm the Earth system. And so, for example, as it warms, glaciers move backwards, and permafrost, which is frozen ground, has lots of carbon dioxide and methane in it. And as that permafrost melts, that carbon dioxide gets released in the atmosphere, and that carbon dioxide increases the greenhouse effect, which makes the world warmer, which melts more permafrost, which releases more carbon dioxide. And so temperature and carbon dioxide go hand in hand. As the Earth cools, permafrost absorbs and takes carbon dioxide and methane out of the atmosphere and locks it up. as the earth warms, it releases it. And it's that positive or reinforcing feedback loop that then pushes both temperature and carbon dioxide concentrations into the atmosphere, a higher and also lower, if that makes sense.
No, that's great, great response. Good answer. Just out of curiosity, the graph you showed goes back 800,000 years, and I'd seen that before with the climate project and Inconvenient Truth. How far do you have to go back to find CO2 concentrations at what we're experiencing right now?
That's
You
a
know?
great question, and I don't know that. Millions of years, but
Millions of years though,
I don't know
right? At
how
least
many, I don't
millions,
know how many millions of years, but it's a long time ago.
a
And
long
you know,
time ago.
Earth's system naturally there's been periods where there's been no snow or ice on Earth, and it's been warmer. There's been periods we believe that almost the entire Earth was covered in ice. And so naturally changes happen, but this change is not a natural change. This is a human driven change. And it's not that we can't live in a warmer world. It's the change that's happening so quickly uh, that is going to impact our food supply. That's going to impact so much. We can live in a warmer world. Life has survived in a warm world. It's the rate at which it's changing right now that's making it difficult for us to adapt.
Yeah, what I've heard several people say is, the Earth itself is going to be fine. There's a question is whether or not, we're going to be able to adapt, and life itself, all the, the diversity of species on the planet is going to be capable of surviving
Right.
in sufficient number, given how
Yes.
quickly we're accelerating this. I also had read that the last time there was this much CO2 in the atmosphere, the oceans were somewhere between 12 to 15 feet higher than they are today, which
I think it's even higher, maybe even meters.
that's a concerning scenario or potential reality.
Yes.
Since
Yes.
we just know that given if we're looking at this much CO2 in the atmosphere for at least the next 100 years, hopefully less, but who knows, then it's just inexorable, right? The oceans, sea levels
Yes.
are just going to continue to increase, and they might even accelerate from here.
And so many people live near the coast around the world, like
Right.
cities like Shanghai with 24 million people right on the coast. Yeah,
Cities like Salem.
like Salem. Yes. Yeah.
So, right. Yes. So let's see, where else we got here? Thank you so much for this clear and engaging presentation. What recommendations can you make about how individuals and small groups can impact systemic societal change? It seems to this layperson that most people realize this is happening, but feel powerless to do anything about it. Reference the anecdote too, that people are more able to imagine the end of the world than the end of capitalism. There we go. Oh, Barbara's answering this live. Any thoughts though?
No, that's probably the greatest question. So one thing that scientists are talking about also now is to talk more about it. Right? A lot of people, some, especially like with my students, a lot of them may individually feel this way, but not realize that everybody else has kind of a similar issue. So talking about it, normalizing it, verbalizing it, that's one thing. Educating is another thing, and then voting, right? And if we're gonna change the system, and we live in a democracy, that is one of the ways that we have to bring about change. Certainly, educating ourselves, talking about it, voting, and then if you have more energy, um, uh, um, right. I actually for a while worked for Greenpeace, and direct action was a way that change would come about. And I know there's a lot of examples where people stand up and do direct action, and change comes from that. Um, so there's a whole range of what the individual can do, and of course, we need to try to be an example, right? Be the change you want to see, and eat less meat, and transport with less carbon dioxide. So there's those individual things we can do too. And it's great that you've got this organization together, to educate yourselves on a variety of issues. And certainly, one speaker may invigorate someone to do something.
Yeah, it certainly is. And let me just note, since you raised the concern and the issue of the private jet expansion at Hanscom Airfield, there is a group that's organizing in this area and around the state. They have a website. It's stopprivatejetexpansion.org. And hopefully we can get them to join us for an upcoming
Yes.
program at some point.
Yes.
But I think the expansion of any private jet travel is deeply problematic given the disproportionate amount of emissions created by jet travel in general,
Right.
and then especially per capita by private jet travel, Learjets and whatnot. That's
Right.
just ridiculous given what we're up against.
And it touches on that issue of inequality, which is prevalent through so many areas of our society now.
Evan, do you I don't want to hog the good professor here. If you have anything to add, feel free. I know Tom has a couple other excellent comments here that I want to get to. Marie Durant is saying amazing talk. Is it recorded? Yes, it is recorded. This will be posted on the Metro West Climate Solutions website in the next day or so. Evan?
You touched on this, but maybe it'd be a good idea to, if this is correct, that the disproportionate warming in New England is really the influence of the warmer ocean, right? That's knocking the shore, or are there other factors?
There's other factors. So one is areas around the world that are cold are warming faster than areas that are warm. So areas with higher latitude are warming faster. So the whole northern portion of continental United States is warming, although we're warming faster. That's just one factor, is those cold areas are warming faster than the warmer areas. Second is, with the decreasing snow cover, we're getting more absorption of energy and less reflection of energy occurring. And then you've got the heating of the ocean, which is also adding. And there are some potential broad weather patterns that are changing as well, that can add to the heating. So it's a variety of factors. I would say the biggest factor is that we're a cold region of the world, and cold regions of the world are warming faster than warm regions.
That's great. Thank you.
Steve, there's a question, or Tom had a good point about the Intergovernmental Panel on Climate Change reports. Just parenthetically, that's the largest assembly of scientists to ever study any natural phenomenon in human history. It is a remarkable achievement that's occurred over the last 30 years or so. But Tom asks, hasn't the IPCC reports consistently understated the impacts? And with each report, they seem to find things that are worse than they thought before. Any thoughts, any comments on that?
Yeah, so scientists are cautious, are skeptical. And so we often when we model the future, we often have a high range and a low range, and we do tend to be more conservative. And I pointed out on that moisture chart how it's an exponential change. So there's a number of things that are that change exponentially, and begin to create these reinforcing feedbacks. And so some of those things are happening earlier than expected. So yes, we tend to underestimate. Sometimes we overestimate. But the majority is we tend to be more conservative and underestimate the change that's going to happen when we model the future.
And the Earth's physical systems are so complex it can be hard to predict that, even with modeling. I know.
Yes.
Tom also makes the point that Bigelow Laboratories in Maine shows there's a cooling of the deep ocean in the Gulf of Maine that could manifest itself in cooler surface temperatures in the coming years. There's phenomenon like El Nino and El Nina and whatnot. And it's hard to know. But the overall trend is obvious.
One thing I do want to point out is those graphs show up and down, 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 which is right that cooling in the deep in the Gulf of Maine. So as you said, the Earth is so complex, but the long-term trend is very clear.
Um, so, well, I think I think we're good until I want to make sure we respect everyone's time and you, including yours, Steve, but just a couple other final questions for you.
Okay.
One, you talked about citizen activism and what we can do, and that has to be at a societal or, much larger community and infrastructure level than just individual choices and whatnot. Where how are you doing that, and where do you recommend that other people engage with activity like that? What do you tell your students who are concerned about this?
Yeah, so one thing I tell them is I think it was 2017, the Board of Trustees of Salem State were going to, 17-18, we're gonna discuss divestment, and they were not in favor of it. And at their meeting, there were so many students showed up that they unanimously voted to divest from fossil fuels, even though they didn't want to. So there is power. I remind students there is power in their voice, and there's power in our voice. And so I do encourage people to speak up. But the expansion of the airport, I've written letters to my representatives in at the State House, and people that are involved in the analysis or the permitting of it. I think activism like that's important. Um, the individual and the group. And for me, it's about education. That's how I see my role, my individual role in climate change. An engineer may see their role differently. But yeah, mine is education.
I think there's some amazing advocacy groups and revisioning groups out there that
Yes.
are coming to the fore, like the Regeneration Project, Repower America, the Post Carbon Institute. There's a lot of really smart policymakers and engineering types who are showing the path forward to a low or
Right.
no carbon world and society if we choose to pursue it. We
Right.
choose to pursue that direction.
And I do remind my students that we know what to do, and we can do it, and things can change, and the momentum can change. And
Um, and it sounds like that's what gives you hope as a person and as a
yes,
scholar and as a scientist.
I'm not optimistic, but I am hopeful.
Good point. Yeah, fair enough. Fair enough. Uh, Thank you, Professor Young. This is part 3 of a 3-part series that Metro West Climate Solutions Group hosted. Our 2 previous programs are already on our website, including a review of the Massachusetts Climate Change Plan, and also a discussion about legislation that occurred last week. In fact, if anyone missed that or wants to know what to do, they could go and listen to the presentation from the Environmental League of Massachusetts about legislative options and whatnot, including House Bill number 4305, which I believe is going to be turned into the final climate bill here in the state, and I encourage people to be in touch with their legislators, be it Michael Barrett around here or Joan Lovely up on the North Shore.
Yep.
Make sure we have a strong climate bill in the next month or so. And then this one with you. So thank you very much for being here this evening. Evan, I will give you any final word, or Professor Young here.
Thank you for a comprehensive, crystal clear rallying call for all of us, rooted in science. What could be better?
Well, thank you very much for letting me reach out and talk with you. And it sounds like a great organization that you've got to learn about climate change and action.
Thank you. Thank you, Professor Young. Thank you, Evan. Metro West Climate Solutions will be back. Stay tuned for future announcements about our programming. Thank you all very much. Enjoy the summer, enjoy some of the heat, and work for change.
All right.
Cheers. Good night.
Bye. Thank you.